In this lesson, we're going to take a look at how does your brain locate objects. So how does your brain identify the position of an object that you're looking at? And why do we see an image when we look into a mirror? So have your handout ready. And looking at number 1, it says for each situation, identify and label where the light rays originated and where he sees the object. So these are the eyes here. And we have several light rays coming to the eyes. So you want to take your ruler and extend each one of those light rays back. Doing that, we find that all those light rays originated from this point. So when your eye and your brain system receives these light rays, it kind of extrapolates backwards, figures out those all came from here, and identifies this as the location of the object, the location of those light rays. So this point could be, say it could be the point on the surface of an apple, okay, that's emitting light in all directions because it is a rough, relatively rough surface. So light goes in all directions. Several of those light rays reach your eye. Your brain-eye system extrapolates backwards and figures out that this is where they came from and identifies that point on the object. Pause the video now and go ahead and do the second one. After you've drawn your light rays, you'll find that all three intersect here. So the brain-eye system concludes that the object where these light rays began was at this location. Number 3, what happens if there is a mirror? So this is really interesting when there's a mirror between the object and the eyes. As you can see, the object here, maybe it's once again an apple or a table or a chair, is reflecting light rays in many directions. And I've drawn here only 3 of those light rays that hit the mirror. In reality, right, there would be many more that would hit the mirror. So 3 light rays that hit the mirror, and then using the law of reflection, I measured the angles and I made the reflected ray go out at the same angle as the incident ray came in. So that's how this picture was drawn. So we have an incident ray, a reflected ray. Those angles are equal. So these 3 light rays that left the object, after they bounce off the mirror, are headed in these directions. So the eye brain system receives these light rays and it extrapolates backwards. It says, where did these light rays come from? So it does this process of figuring out this light ray probably came from this direction. And this light ray probably came from this direction. And this light ray probably came from this direction. And I don't have a very good intersection point here. I'm hoping yours turned out a little bit better. So the intersection point is about right here. So the person is going to identify the position of the thing they're looking at, or the thing they're seeing, as right here, as behind the mirror. And when you look in a mirror, it really does look like there's something behind the mirror. And that is because of the direction that these light rays are traveling when they get to your eye, and how your brain-eye system works backwards to locate where they came from. Now really they came from over here, but the mirror kind of fools the eye brain and makes it see something that's not actually there. So the reason the person doesn't correctly identify the location of the object is because the mirror has changed the direction of the light rays. This type of image is called a virtual image. And it's called a virtual image because there are not real light rays intersecting at this point. These are imagined extensions of real light rays. If you had actual real light rays intersecting, which is what we'll have when we get to working with lenses and light rays that travel through lenses, then we will have real images in some cases, because we will have actual real light rays that are intersecting to make the image. But here the image is virtual because these are not real light rays. And one thing you can do is you can try to draw these rays behind the mirror with dashed lines. That's one way you can distinguish between them, but you don't have to do that. Now on the back side, we're going to apply this idea. Draw at least 3 light rays that bounce off the object and hit the mirror. Measure and draw each reflected ray and extrapolate backwards to find the point where the rays appear to have come from. Draw in the image. So in this diagram, this line is the mirror, this is the object, and it's actually kind of a large object, so I'm just going to pick the upper left-hand corner to draw my light rays from, and just pretend that, let's just make a small dot here instead of a square. And you have to infer from the diagram that this is the reflective surface of the mirror, because we're assuming these light rays are going to reflect off. You will need a protractor and a ruler to do the next part. You can draw your 3 light rays anywhere you like. I am going to start with a light ray going down. Okay, now I need to know the incident angle. The incident angle is measured from the normal. So I need to construct a perpendicular here. I think I'm going to use my protractor to do that. So get this lined up. Mark the 90-degree spot. That will enable me to make a normal. And now I can measure my incident angle. This angle here between the normal and the incident ray is the angle of incidence. And it looks like that angle is about 28 degrees. And that means I need to make a reflected angle that is also 28 degrees. So now we can draw in the reflected ray. Now you have to imagine an observer over here. Here's my humongous eyeball, receiving all these light rays. So when the brain eye system receives this light ray, where does it think that light ray came from? It thinks that light ray came from back here. Okay, so this is a virtual light ray, not really there, it's imagined. And that's it for the first light ray. Go ahead now and do your next 2 light rays and find the place where they intersect behind the mirror. For my third light ray, I'm going to do what I call the easy ray, which is a light ray that goes straight into the mirror and comes straight back out. So this light ray is going to go straight in like this, and since the angle of incidence is 0, the angle of reflection will also be 0, and that light ray goes right back out. But where does the brain think that light ray came from? Thinks it came from this direction. And we see we have an intersection of the light rays. Even if you did light rays at different angles, all the light rays that leave this point and hit the mirror, when extrapolated backwards, will intersect at one point. So the image of this point is here, and this is a virtual image because those are not actual real light rays intersecting there. Those are imagined extensions of light rays. Number 5. In number 5, we are going to identify the location of the image for 3 different points and then actually draw in the image of this triangle as it would appear in the mirror. It says draw at least 2 rays from each point that hit the mirror. Show the reflected ray and draw where each ray appears to have come from to locate its image. So I'm going to do point B first. And the reason there's a grid here is so that you won't need to measure angles. So I'm going to, for my first light ray, going to go up 3 squares. So it goes over 3 and up 3. So to get the same angle for my reflected ray, I would need to go over 3 and back 3. So if I connect these 2 points, that will give me a ray at the same angle as that one. So this light ray reflects this direction. Where does the observer that's over here looking at the mirror think this light ray came from? They are going to think it came from back here. And I'm going to draw my next light ray down here. It's going to go over 3 squares and down 2 squares. So try to put arrows on your light rays. The reflected ray then needs to go over 2 and back 3. So it's going to have this angle. And that light ray, the brain is going to think that one came from here. So here is my image of point B. Now go ahead and find the image of points A and C. Once you have located the mirror image of each point, so here's actual point A on the object, here's the image of point A, here's the actual point B on the object, here's the image of B, and here's the actual point C, here's the image of C. You're ready to draw in the whole image. So to do that, we can connect the points. So B to C. A to C, and A to B. And you'll notice that it does look like the mirror image, that there is a mirror symmetry across this line. If you were to fold the paper, this would be right on top of that. That's one way you can tell that you have drawn your light rays correctly. So, overview of the big ideas here are that when a light ray hits the mirror, it reflects off at the same angle. Sometimes we will measure the angles. Other times we will have a grid to make it a little bit faster. When the observer, so imagine a large eye over here, receives these reflected light rays from a point, it extrapolates backwards to find where it thinks those light rays came from. So these light rays from point B, the brain receiving these light rays says, those light rays, they came from these directions, so they must have come from something located here. And it puts together a picture of that thing at that point, which we know is not really there. It's kind of like it got tricked by the mirror, which changed the direction of the light ray.